Hi there, and welcome to this practice set on slope. Be sure to like this video if you find it helpful and subscribe for more math content. Drop a comment or question and let me know what you think. So pause the video here to work these problems on your own and then come back to check your work. Great. So these first problems are asking you to find the slope from the graph. And I think these are really important. What I've noticed in my students is as we get further on in our discussion of lines and working with slope, students forget that this is a thing that you can do. And so it's good to take a couple of problems at the outset and remember that you can find the slope from a graph pretty much anytime that you're able to identify points. And so what we look for are what are called lattice points. My engineering students, we do this and I have to define what they are. But if you look at what I'm doing over there on the graph, the lattice points are the points where the grid lines intersect. So while it's true that, say, this is a point, if you can see where I put it, turn the pointer on, like right there. I don't really know where that point is. It's somewhere between -1 and -2 on the x-axis and somewhere between 7 and 8 on the y-axis, but I don't really know where that is. It's a point on the plane, but it's not a particularly useful point. So what we do when we're looking at the line is we're going to look to see if we can find lattice points. So I see a lattice point right there at 2, 2. And I see another lattice point here at 4, 1. But there's other lattice points. So there's one over here at, what is that, -8, +7. I see one here at -2, +4, and you can pick any two lattice points you want. And remember that your slope is that ratio of rise over run, or it's that change in y over the change in x. So pick any 2 points, and I'll pick these two over here on the left. And to get from one point to the other, I have to go down 1, 2, 3 units. And remember that you're counting spaces. So down 3 units will be represented with a -3. And then I will go over 1, 2, 3, 4, 5, 6 units. So my slope is -3/6, or I can simplify that to -1/2. And we could have picked another set of points. So I could have picked this set here. Okay, the 2, 2 and the 4, 1. And there you can see I am going down 1 and to the right 2. So that's the first one. Don't forget, you can do that. We have another one like that. So let's go find ourselves some lattice points here. So what do I see? I see one right there. That looks like that's the point 3, 7. And I see one here that looks like it's at 2, 4. And we'll that's a super messy triangle. I believe I am capable of giving you guys a better triangle than that. There we go. Okay, so the slope is the rise over the run. And so to get from one point to the other, I need to go up 1, 2, 3. So my rise is 3 and my run is 1. And of course, 3 over 1 will simplify to 3. Now, you might be saying to yourself, well, what if I made my triangle the other way? So what if you picked these 2 points and you did this? Okay, and so your triangle is kind of on the other side of the line there. I don't really recommend that, but let's just say you did. In that case, your rise to get from one point to the other, if you were to start here, you'd be going down 3 and then left 1. Okay, and so down 3 would be -3 and left 1 would be -1 because you're moving in that negative direction, and a negative divided by a negative would give you a positive. So you actually can work that either way. Up to you, like how you want to view that, but I would always count the rise first, just be in the habit of doing. All right, so this is a a little bit more practice. So 3 through 5, number them however you want. Find the slope of each line. So I'm going to go and find the slope of the orange line, and we'll pick a couple points on the orange line. And what I see is I am going down 1 and right 1. So down 1 is -1 is my rise, and right 1 is +1 for my run. And so -1 divided by 1 is -1. Looking at the blue line. We're going to find some points here. Try to get it. I was looking up at the left there, but it's a little crowded up there. Let's come down here. So I see right there. And again, we're doing rise over run. So it looks like I go down 1, 2, 3 and right 2. So the slope is -3/2. And looking at our green line. So we're going to find some points on that green line. And where do we want to go? We'll do here and here. So I could go like up to that area, but it just looks a little crowded up there. So just steer clear of that. All right, so it looks like I'm going down 3 and right 1. Did I count that right? 1, 2, 3. Yep. And right 1. And question 6 is asking you, what do all 3 lines have in common? Now, you might have thought of some different things here, but what I was looking for when I wrote that problem was that they tilt down from left to right. And this gets into some important concepts with slope. So whenever you see a negative slope, it means the line is going to tilt down. If the slope is positive, it tilts up. And so that's an important thing. And if the slope is 0, it will be a horizontal line. And you do want to be careful when you say 0. Don't say it doesn't have any slope, because if we're talking about a vertical line, the slope is undefined, but we won't touch that right now. All right, so these ones are all finding the slope with the formula. And so your work might look a little different from mine, but the answer should be the same. So I strongly, strongly recommend writing down the formula for every problem. It helps you memorize it. So the formula for slope, we want that locked into your long-term memory. So just writing it down, writing it down, writing it down, just keep writing it down. I know you might not need to if you've got it sitting in front of you on a separate piece of paper. Just write it down anyway, like make your hand do it. Now for this first one, we can pick either point we want for point 1 or point 2. I'm going to pick this as point 1 and this is point 2. Now the other way will work, okay? So y2 is the y coordinate of point 2, so that is 10, minus y1, which is the y coordinate of point 1, so that's 4. And then x2 is the x coordinate of point 2, and x1 is the x coordinate of point 1. 10 minus 4 is 6. 7 minus 3 is 4. And then you should simplify that to 3 over 2. If you pick the points the other way, you would have wound up with this. You would have had 4 minus 10 over 3 minus 7, which would have given you -6 over -4, and a negative divided by a negative is a positive. So it should land you in the same spot. With experience, you will get good at seeing if there's a better way to pick the points. There's not a wrong way. Just if we can avoid the negatives, it's usually considered better if we can. The second one, so again, just write down that slope. You can time how long it takes me to write it down. Does not take too long. And what do we have here? So I guess I'll do, I don't know, well, I will be consistent. We'll say point 1 and point 2 again. So y2 in this case is -2 minus 4. And we'll have 6 minus -3. Now, I I am going to make a recommendation here because we have a lot of negatives swimming in this problem. So we have a negative out front, we have 2 minus signs, and then we have this. Do be careful of this. The first minus is coming from the formula, okay? And the second minus is coming in on that -3, okay? I'm going to strongly recommend that you do a subtraction is addition of the opposite here, because a lot of students will see -2 minus 4 and they'll like go in the wrong direction. So they'll try to make like the -2, like, and they'll go -1, 0, and yeah. So this is -2 plus -4. And then in your denominator, that becomes 6 plus +3, because you're always adding the opposite, and the opposite of -3 is +3. So this makes it a little bit easier to see. So -2 plus -4 is -6. 6 plus 3 is 9. And we can simplify that because 6 and 9 are both divisible by 3. So that is what? -2/3. And last but not least, we are writing down our formula. Okay, and let's pick it the other way this time. So let's do 0.2 and 0.1, just because I don't want to get myself into this habit where I'm always picking them the same way. And then if you're following along, you think, oh, I've always got to pick them this way. No, you can pick them either way. So what do we have going on here? Y2 in this case is 4.5 minus Y1, which is a -6, over x2, which is 0 minus 3.7. So what is happening here? So minus a negative, so that would be adding the opposite. The opposite of -6 is 6. And 0 minus 3.7 is -3.7. So we have 10.5 divided by -3.7. And I would probably recommend grabbing a calculator at this point. I'm also not a huge fan of the negative being in the denominator. And I think I've gone over this in other videos, why you can move the negative just up to the numerator. What you could do here is multiply everything by 10. And so you could get 105 over 37, which I don't think divides evenly and can, like, there's no common factors there. So I think that's actually as simple as you can get it. Typically, we don't want to mix decimals in the fractions, but follow your teacher's direction, or you could change the whole thing to a decimal. So that's one where you just follow the directions for what your teacher might want. The point of that problem is to throw decimals in there in situations where doing this on the graph would not be a good option. All right, and this one, so this is a great one. So what is the slope and what does it represent? So I want to call your attention to a couple of things. Obviously, this has been scaled a little weird. So the distance on the x-axis for like 1, 2, 3 does not match the distance on the y. And that's okay to do. You can also opt to count by like 2s or 4s, 5s, 10s on one axis and something different on the other axis. What's important is that your scaling is consistent. So once you're on an axis, the same distance represents the same intervals. So you wouldn't want to have like a small intervals and then big ones and counting by ones. And you also don't start counting by something different. I will often see students go 1, 2, 4, 6, and no. Okay, so once you pick an axis, you have to stay consistent, but the two axes don't need to be the same. All right, so let's go find some points on this graph. I see one right here, and I see one right there. And so we could do this a couple of different ways. We could count it, the rise over the run. We could look at the coordinates of those points. So that is the point 315 and what, 210. Let's do it that way, because that will help us answer the next question. So here we go. So y2, I'm going to make this 0.2 because the numbers are bigger across the board, and that'll make my subtraction nicer. So we have 15 minus y1, which is 10, over 3 minus 2. 15 minus 10 is 5. 3 minus 2 is 1, and so the slope is 5. So that's the slope. So the slope of this line is 5. Now, the more interesting question, because I love interesting questions, is what does it represent? And this time, like my students, I'll get all kinds of answers. Like, it represents M, it represents the slope. Yes, I know. So here's how you can figure that out. On your y-axis, okay, so you've got your change in y over your change in x. In your y-axis, if you look at the label on this, it is distance in miles. And so I'm going to go and say, like, that number is measured in miles, whatever that number is. So you have 15 miles minus 10 miles. Look at that. So that's what it is. On your x-axis, you have time measured in hours. And so you have 3 hours minus 2 hours, but the unit on that is hours. The unit on the answer comes directly out of the slope formula. We are dealing with miles on the y-axis and time on the x-axis. So this would be 5 miles per hour. If you can get the unit, it will probably tell you what it represents. And the answer to what does it represent, if it is 5 miles per hour, is speed. So the slope in this problem represents the speed. When you're finding the slope of the line, you are actually finding the speed of the object. So something going 5 miles per hour could be a person running. It could be like a bicycle. It would be a little bit slow bicycle, but still a bicycle. Yeah. So that's, like, again, the more interesting question, I think, is what does it represent? Why is slope an interesting thing? All right, as always, don't forget, give this video a thumbs up if it was helpful to you. Subscribe for more math content and drop me a comment or a question. Let me know what you think of this video, of the problem set, if you have any questions, else you'd like to see a video on, and I will do my best to get back to you. All right, have a good one. I will see you in the next video.